What if the universe isn't actually playing dice? For the better part of a century, we've just kind of accepted that randomness is baked into the very fabric of reality. But today, we're going to dig into a pretty wild new theory that suggests there's a hidden order to, well, everything. So let me ask you this. For almost 100 years, science has told us that down at the very smallest scales, the universe is fundamentally unpredictable. It's all just a game of cosmic chance. But what if that's not the whole picture? What if there's a secret set of rules, a hidden pattern, pulling the strings behind the scenes? That is the giant question behind a new framework called Fractal Resonance Cognition.
All right, so here's our game plan. We're going to break this whole thing down piece by piece. First, we'll look at the problem it's trying to solve. Then we'll get into this idea of a hidden order, unpack how it all works, see if it can really crack the measurement mystery, and then we'll zoom out and look at its incredibly ambitious goal to create a unifying map of reality itself.
Okay, first things first. We have to really understand the puzzle we're trying to solve here. And trust me, it's a big one. It's a mystery that has kept physicists up at night for decades. The problem of randomness in the quantum world.
So according to the standard way of thinking, a tiny particle like an electron is just a smear of possibilities. It's everywhere and nowhere at once. They call this superposition. But the second we try to measure it, the instant we look, that whole cloud of possibility just snaps into one single definite spot. And here's the real kicker. Where it decides to show up is believed to be completely 100% random. Why this happens and how just looking at something forces its hand, well, that's the infamous measurement problem.
And this is where Fractal Resonance Cognition, or FRC for short, just walks right onto the stage. It suggests something radical. Maybe what looks like pure randomness isn't random at all. Maybe it's a sign of a much deeper, more orderly process that we just haven't been able to see until now.
So the theory's big idea is this. What we mistake for chance is actually the result of very specific, structured forces that are happening on these incredibly complex fractal levels. So it's not a cosmic roll of the dice, it's more like a beautifully intricate, hidden machine, humming away in the background.
So let's just put this side by side to make it super clear. On one hand, you have the standard view. The particle collapses, and where it lands is totally random. The end. But on the other hand, this new FRC view says, no, the collapse is actually guided. It's totally deterministic, as long as you can understand the hidden fractal patterns that are influencing it.
Okay, so if it's not random, how does this hidden guidance actually work? Well, the clue is right there in the name, fractal resonance. To really get it, we need to quickly break down both of those words.
So a fractal, you've definitely seen these before. It's basically a pattern that just keeps repeating itself no matter how far you zoom in or out. Think about a coastline from space versus standing on the beach. The same kind of jagged patterns show up. Or a snowflake, right? The tiny little branches look just like the big arms. That's self-similarity. And resonance, well, resonance is something we all know intuitively. When you push a kid on a swing, you have to push at just the right time, right? Match its natural rhythm. And when you do, it goes higher and higher. That's resonance. It's all about a system getting super excited by one specific frequency or pattern.
Okay, now let's put it together. This is where it gets really cool. The theory says there's this hidden energy field, a fractal potential, that's always interacting with quantum systems. So on the left, you see what the particle's probable locations normally look like. It's a nice, smooth curve. But look at what happens on the right. When you add that fractal influence, that smooth curve shatters into all these intricate, spiky, resonant peaks. These new complex peaks and valleys create these super stable points called vortex attractors. And honestly, the best way to think of them is like tiny, invisible whirlpools. The idea is that when we measure a particle, it doesn't just randomly pick a spot. Nope. It gets caught in the current of one of these whirlpools and is guided, predictably, right into that stable, resonant state. So we've got a mechanism, right? Hidden fractal patterns creating these little whirlpools. But how does this actually solve the big measurement mystery? How does it connect these hidden rules to the actual results we see in our labs every day?
And I know what you're thinking, because this is the million-dollar question. If the whole process is guided and predictable, then why, for 100 years, have all of our experiments screamed randomness at us? Why does it look like pure chance?
Well, you're going to love this. The FRC model actually has a perfect answer. It shows that even though every single measurement is deterministic, each particle being guided into a whirlpool, if you do it over and over and over again, the pattern of where they end up perfectly matches the probabilities from standard quantum mechanics. The model spits out the exact same predictions as the famous Born rule. Just look at the graph. The theory's results land right on the money. But here's what makes this a really big deal. FRC isn't just a cool story or a philosophical idea. It's a legit, testable scientific theory. It makes very specific predictions that we can actually go out and look for. Scientists can hunt for things like fractal patterns in quantum data, or for energy levels that are spaced out like musical harmonies, or for certain types of correlations that follow what's called a power law.
For example, take a look at this. This graph shows exactly the kind of evidence they'd be searching for. If real-world experimental data lines up into a straight line like this on a special kind of plot, it would be a huge smoking gun, powerful evidence for the kind of hidden fractal structure that FRC predicts.
But hold on, because the ambition here goes way, way beyond just the quantum world. The authors of this framework are suggesting that this principle of fractal resonance might be a fundamental organizing rule for pretty much all complex systems. We're talking from our own brains all the way up to the entire cosmos. The thinking is that this same dynamic, this process of an underlying deterministic pattern creating what looks like chaos, could be happening absolutely everywhere. It might be the secret to how neurons fire in our brain, how galaxies clump together in space, or maybe even how advanced AIs actually learn. And this image, wow, it just captures that grand vision perfectly, doesn't it? The idea is that one single fundamental rule could be the bridge that connects the weird, chaotic dance of quantum particles on the left with the orderly, predictable waves of our everyday world on the right. It's a proposed link between the micro and the macro. So we're left with this really provocative thought. Could a simple idea, patterns resonating with other patterns, be the hidden language of the universe, the fundamental instruction set that nature uses to build everything at every single scale? It's a huge idea, and it reframes randomness not as a law of nature, but maybe just as a veil, hiding a much deeper, more beautiful, and intricate order. A question definitely worth thinking about.